Okay, this section 11.2 and the problem set is on page 849. Page 849. It's about arithmetic sequences, and hopefully you watched the other formulas, the other videos on this first. Here are objectives. The book does it a little more fancy than we have to do it. So basically they want to show that the first set we're going to do is show that each sequence is arithmetic and find the common difference and write out the first four terms. Now, if you want to, you can write out the first four terms, then find the common difference. If you have a common difference, that means the sequence is arithmetic. So basically, let's do 3. 3 is n plus 4, so I have to write out the first four terms: ace of 1, ace of 2, ace of 3, and ace of 4. So I'm going to plug in 1. 1 plus 4 is 5. 2 plus 4 is 6. And then we're going to plug in 3, and we get 7, and then we're going to get 8. So basically, the common difference, so D equals 1. Therefore, since it has a common difference, that means it is arithmetic. Okay? Let's do 9. So let's look at 9. We have 1/2 minus 1/3 n. We have to write out the first four terms. And the first four terms are, I plug all this in, I'm going to get 1/6. So I plug in 1. Then I get 1/2 minus 1/3. And you can use a calculator, so that's going to be ace of 1 equals 1/6. Ace of 2 equals negative 1/6. Ace of 3 equals, if I'm doing my math right, it's negative 1/2. And ace of 4 is negative 5/6. Now, to find the common difference, all you have to do is divide. I'm not sure if these two are right. Let's see. I'm going to plug in 2, so we're going to get 1/2 minus 2/3, which is going to be 3 over 6 minus 4 over 6. Yeah, it is negative 1/6. When you find the common difference by dividing, you'll find the common difference is negative 1/3. Since it does have a common difference, that means it is arithmetic. All right, let's do one with ln. So let's do 11. 11 states ln of 3 to the n. All right, so ln of 3 to the n is going to be, I'm going to write out the terms, and I'm going to get, the first term is ln 3 to the 1, which is 3. This is the first term. The second term is going to be ln of 3 squared, which is 9. Cubed one's going to be ln of 3 cubed. And ace to the 4 is going to be ln of 3 to the 4th. And if I write this out, I could write it out as ln of 3, 2 times ln of 3, 3 times ln of 3, and 4 times ln of 3. Okay, to find the common difference is ln of 3. Okay, so basically the way you would do that is you just subtract ln of the next term minus ln of the current term, and that's going to give you m plus 1 times ln of 3 minus n times ln of 3, and then I'm going to pull out ln of 3 and get m plus 1 minus n, and that gives me ln of 3. So that's your common difference. Therefore, it is arithmetic. Okay? Now we're going to find the nth term of the arithmetic sequence whose initial term and common difference are given. And then we also have to find what is the fifth term. So basically, we know we already have two formulas. We have, we have this formula, a sub n equals a sub 1 plus n minus 1 times d. So if I do 13, and I want to find the fifth term, I'm going to write this as, first of all, a is 1, or a is 2, and d is 3. And since we're finding the fifth term, n is what? 5. So the fifth term is, what is this? 2. Alright, so we get 2 plus 4 times 3, which equals 14. Okay. Let's see if we can find a more interesting one. Let's do 19. So 19, we have the first term is root 2, and the common difference equals root 2. And I think we did one like this already. We'll do it again. So we're going to get root 2 plus 4 times root 2. And if I want, that's going to be 5 root 2. So a sub 5, we're looking for a sub 5, equals 5 root 2. And that's as simple as it gets. Okay, let's do the next set is we have to find the first term and the common difference and give a recursive formula and a formula for the nth term. So the next set is the harder set. So we're going to start with 27. And we have the 8th term is 8. And the 20th term is 44. So what we're going to do is solve the equation by subtracting the first one from the second one. So what I'm going to set up is two equations. I'm going to set up a sub 8 equals a plus 7d, and we know this equals what? 8. And a sub 20 equals your first term plus 19d equals 44. Now, when we subtract the first from equation from the second, we're going to get 12d equals 36. And so d equals 3. So your common difference equals d. Now, to write out a recursive formula, we have a sub 1 equals negative 13. Well, first of all, we got to find, I'm skipping. So first of all, we know the first term equals 8 minus 7 times 3, which equals 8 minus 21, which equals negative 13. So the recursive formula is a sub 1 equals negative 13, and a sub n, therefore, equals the previous term plus your common difference of what? 3. Now for the nth term, so there's your recursive formula. So your recursive formula, we have a sub 1, or the nth term, sorry, we already did that part, is a sub n equals a plus m minus 1 times d. So we have this equals negative 13 plus n minus 1 times 3, which gives us 3n minus 16. Because basically I did right here negative 13 plus 3n minus 3. And that is your nth term. A little different than what we did before, but nth term. Okay? Alright, let's do another one like that. Let's do 29. And there's an example in the book on this as well, if you want to look at it. Ninth term is negative 5. And the 15th term is 31. So the way we're going to set this up is write it as a system of linear equations. So we're going to do a of 9 equals a plus 8d. Remember, n minus 1 times d. And we know that this equals negative 5. So basically I'm just using the formula. This is your n minus 1 part here. All right? And then the way we're doing this is we're trying to find d. And now we have a plus 14d equals 31. Now, when you subtract the second one from the first, you're going to get that these two a's will cancel. And we already know that this is my a sub 9 and a sub 15. So we're going to get, when we subtract, we're going to get blah, blah, blah. Solve it. What do we get? Negative 6d equals negative 36. So d is 6. So when you write your formula, you're just going to write, well, a sub n equals a sub 1 plus m minus 1 times d, which is what? 6. And, we have to do recursive formula, sorry. So it's going to be a sub n equals the previous term plus your 6. Because if the common difference is 6, you're just adding 6. So this is your previous term and this is your current term. So it's pretty easy. Now we have to find the nth term. So the nth term is a sub n equals a, that's your first term, plus m minus 1 times d. So a is negative 53 plus m minus 1 times 6. And that gives us our formula, which is 6n minus 59. And that's after you distribute that and add. Okay? All right. Okay, you want to do one more of these? We can do 33. So 33, we have the 14th term equals negative 1, and the 18th term is negative 9. So we're going to write this as a of 14 equals first term plus 13d, which we already know equals what? Negative 1. A sub 18 equals a plus 17d, which equals negative 9. We're going to subtract all this, and we'll get negative 4d equals negative 8. No, this is going to be plus 8. My pen doesn't work when it wants to. Okay, so d equals negative 2. Now, so to find a is going to be negative 5 minus 8 times 6, which gives you negative, wait, which we're on 33, so I'm doing the wrong one. So to find A, we're going to do negative 1, which is here, minus 13 times negative 2, and that gives us 25. Okay, now we have to write our two formulas. And what we're going to get is recursive formula for, we're going to have a sub n equals the previous term minus 2, because that my common difference was negative 2. And my nth term is going to be the first term plus n minus 1 times d. And we figured out our first term was 25 plus n minus 1 times negative 2. Distribute and collect terms, and you're going to get negative 2n plus 27. And that is your nth term. Okay? Now, in this next set of problems, we're going to find each sum. So we have 35. 35, we have 1 plus 3 plus 5 plus dot 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 plus 2n minus 1. Okay, so the way you do this one is we're just going to use, we define the sum. In this case, this is a series now. It's the section's labeled sequences, but since we're adding it. So all I'm going to do is use the formula we did last time. So basically we're doing the same thing we did last time. N over 2 times a sub 1 plus a sub n. So the first term, 35. Okay, so the first term, I'm going to plug in 1, and I get 1. And so I'm going to get n over 2 times 1 plus, and my last term is this one, so we're going to write 2n minus 1. I clean this up, and I'm going to get n over 2 times 2n, which equals n squared. So that's how you do that. I'm just cleaning this up. This is 1 plus 2n minus 1, so you get 2n. The 2's cancel here, so you get n squared. Okay, 37, same kind of thing. It's pretty easy. You have 7 plus 12 plus 17 plus dot 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 plus 2 plus 5n. Now, we're just going to use our special formula. Make sure you have this memorized for the SAT. So we have n over 2, a sub 1 is 7. It's right there. Plus the last term. So this is your first term, and this is your last term. And I'll put that in. So that's 2 plus 5n, 5 sub n, and then clean it up. Get n over 2 times 9 plus 5n. And that should be all you can do there. It's so easy. Okay, any more? Let's do one that doesn't have a sum. So let's do 39. So 39, we have 2 plus 4 plus 6 plus dot 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 plus 70. And I'm going to use my formula. We don't know how many terms we have, so we're just going to write 2 plus 70. So we get n over 2 and 72, which actually equals 36n. And that's your formula. Okay? We do know we have 35 terms, so if you want to let n equal 35, you can write this as 36 times 35, and that's going to equal 1260. Okay, let's do another one like that. In this case, we're going to let's do 41. We have 5 plus 9 plus 13 plus ... plus 49. Common difference is 4. So what we're going to do on 41 is let A1 equal 5. My D equals 4, because the common difference is 4. And I'm going to use first the formula A sub n equals A plus n minus 1 times D to find my number of terms. So A sub n equals 5 plus n minus 1 times 4. And A sub n is my last term, that's 49. So we're going to get 49 equals 5 plus 4n minus 4. So we get 48 equals 4n. So n equals 12. Now we just use our formula. S of n equals 12 over 2 and 5 plus 49. And that's all going to equal 324. Okay? And that's all.